Our first topic is just going to be exploring the efficiency of NumPy arrays in comparison with Python lists. And here we are importing NumPy as NP. We can use it as this alias NP. And here we're creating a range of elements from 0 to 1,000,000. And also here we're creating a Python list of elements from 0 to 1,000,000. So these are comparable sequences. Now we're going to use the time magic function in order to multiply these. Now we're going to multiply the NumPy array by a factor of 2, and then we're also going to multiply the Python list by a factor of 2. So again, these also are congruent operations, and this magic function is going to tell us how much time it takes to do that. So let's make sure we have NumPy available. Now let's create our two arrays. Now let's test the NumPy array and see how fast that runs. 21 milliseconds. And then let's see how fast it takes to run the same operation in Python. 434 milliseconds. So we're doing the exact same operation with the same data. As you can see, NumPy operates on it much faster. Now there's some reasons for this based on data size and also the way that NumPy data is organized in the computer's memory. The point is that NumPy is much more efficient than native Python. Now below here we're going to use random and randend. These are functions that we were introduced to in the Python course. We never really talked about what they mean, however, and so at this point we would like to discuss that a little bit. Randend is rand normalized, and what normalized means, if I can just draw this here. Imagine you have a number line, and this is 0, and this is -1, and this is +1. Now when we normalize data, what we're talking about is centering the data on 0 and creating a standard deviation between -1 and 1. So what that means is the average, the mean of your data is going to be clustered around 0, and then the rest of your data is going to be dispersed on a random deviation between 0 and 1. So like most of your data is going to be clustered here. You may have some outliers that get up, into the 2 or possibly even into the 3 range, but what you're doing is clustering most of your data around here. So anything that is less than the mean is going to be negative. Anything that is greater than the mean is going to be positive. And you could take an array of data that was between -2,000 or more, right, and +2,000, and you could scale this data down, centering the mean on 0 and scaling this data down so that it would all, for the most part, fit in this normalized distribution. So that's what randend does. Now what we're doing here is we're just creating a random array. We're creating a set of random numbers and we're normalizing them in this way. So that's what that means. Now if you don't have a background in statistics, and don't let this worry you, just understand that when we create random data like this, it's just generic data that we're going to populate our sequences with so that we can explore the operations that are available to us in NumPy, and that the randend method creates them according to this distribution. With that in mind, our next lesson is going to move into NumPy data arrays.